Good afternoon, everyone. Welcome to our interactive workshop with Dr. Bob Metcalfe. It's hard to introduce a legend, I think, so I'll try to be very brief on this, other than to say if he hadn't done what he did, we wouldn't be here. So there we go. So you can read his bio in the book. It's enough for 6 or 7 people, and he's starting yet a new career at his alma mater, MIT, in artificial intelligence. So we'll see what comes out of that. So we're going to operate this. This is interactive, meaning you ask him questions and he answers. If nobody asks questions, nothing happens. So queue up at the mics. The only rule we have, please ask one question, then recycle yourself back to the back of the queue if you have more questions, okay? We don't want to have a bunch of things going on. So at this particular point, I'm very pleased to introduce to you Dr. Robert Metcalfe, the inventor of Ethernet. Bob.
Thank you very much. 50 years ago, testing 1, 2. 50 years ago, on May 22nd, 1973, as you just heard, I invented Ethernet. That means I can be a member of the Connectivity Inventors Society, which meets quarterly. This last meeting was really sad because the inventor of USB had died. So the members of the society served as pallbearers and carried his coffin to the cemetery across the street. And we were lowering his coffin into the grave when it jammed. So we lifted the coffin back out of the grave and we rotated it 180 degrees and we lowered it into the grave. That's a connectivity joke. It's the only one I have. But I have 50 years of stories here, which I hope to make useful to you in our understanding of, and it was 2 subjects, Stephen. It was connectivity and innovation, and the combination thereof. So I can talk about, I don't have any more jokes. Well, not as good as that one. I could talk about the 2 monopolies we had to break to build the internet. I could talk about the very, very early days of the internet. I can talk about why Silicon Valley moved from Boston to Palo Alto. I can talk about how Ethernet was invented and what its key feature, what we thought its key features were. And in retrospect, we were wrong. We learned completely different things. I can talk about the most important new fact in the human condition, which is that we are connected. I could talk about Metcalfe's law. I could talk about the Xerox Palo Alto Research Center. I could talk about 3Com Corporation, a company that I started in order to commercialize Ethernet, and so on. So would anyone like to break the ice with an initial question?
Come on, everybody, I'm counting on you.
He promised.
Get up there. Ask some
promised.
questions. Come on. Come on. This is your once-in-a-lifetime opportunity to get all this stuff from the guy. So get up there. Come on.
Or I'll just tell random stories.
You could do that too. All right. Go ahead. Go to the mic. No.
So maybe I'll pick on Ethernet. You just mentioned that there were a few features you thought would be trivial or important, and then in retrospective, you realized maybe not, maybe something else. What was that journey like? Was it like in one moment, multiple point of time, you realize, okay, this is not relevant as much as we thought? Could you talk about that?
Okay.
Yeah.
So in 1973, Dave Boggs and I were given the job of building a network to connect the world's first personal computer. And by the way, that's highly controversial, but the Xerox Palo Alto Research Center decided to build a PC called the Alto and gave us the job. So we had constraints. We had to finish in 1973. We weren't allowed to take forever because we were building this PC, and we were about to fill the building with PCs, and we needed a network to serve them, in particular to connect them to the laser printer that we were also building. So our first decision was to use coaxial cable. We went to Hawaii, at the University of Hawaii, and they had a radio network called the Aloha network, but the radio modem was this big. But we had the constraint that the network had to fit on a card this big that held 60 dual inline packages, and that was a constraint. So we couldn't use a radio modem that was this big, so we had to wait 25 years for Wi-Fi to come along. So there were the constraints. 1973 had to be finished that year, and it had to be on a card that plugged into this PC. So we chose coaxial cable, and there was a cool thing called a Gerald tap, and I think it probably still exists, that you use to puncture a coax and connect to its center conductor without cutting the cable. We really liked that because we wanted it to be a 24/7 network, not a network. In those days, it was fairly typical you would bring the computer down that night, and we didn't like that idea. So we really liked the Gerald tap. So the shared coax and the Gerald tap was the first design decision. The second design decision is that we were going to use Manchester encoding. So Manchester encoding is the simplest possible encoding. On this cable, every time we put a bit, the bit cell would begin with the bit by turning the voltage on or off, followed by the complement of the bit. So each bit cell was bit complement of the bit, and that guaranteed that there was a transition in the middle of every bit cell, which meant you could recover clock. So we took the clock from the mid-transition and clocked those bits into the shift register, and we had ourselves a network. Very, very simple. So that was the second breakthrough technology we thought we'd made. And then the third one, what was the third one? AlohaNet. The attached PCs had to put their packets on this cable. They had to take turns. How are they going to take turns? You're going to run another wire to each of them to tell them when it's their turn? No. But Hawaii had this method of you just send the packet, and if it gets through, great. And if it doesn't get through, you count down a random number and try again. And the purpose of counting down the random number was to avoid repeated collisions among stations. So those were the three key technologies: the Gerald tap, the Manchester encoding, and the Aloha network, randomized retransmissions. So then 50 years goes by. You may have noticed Ethernet does not use Gerald or Manchester or Aloha network. They're gone. So what was the contribution of Ethernet in its day? And there were, by coincidence, three technologies. First, Ethernet carried packets all the way to the desktop. And prior to Ethernet, the packets stopped at the host mainframe and were converted into an application that sent you characters, ASCII characters, over a dumb terminal. But with Ethernet, for the first time, to welcome the personal computer, made it possible to bring those packets all the way to the desktop. The second contribution is Ethernet brought abundance of bandwidth. The day before Ethernet, I had 300 baud on my desk. The day after Ethernet, I had 2.94 megabits per second. The ratio is about 10,000. So the speed up on my desktop wasn't 10%, it wasn't 100%, it wasn't 1,000%. It was 10,000 times faster. And so there and after, bandwidth was abundant on the internet. It wasn't 300 baud, it was 3 megabits per second. Actually 2.94 megabits per second. And the third contribution is 3Com joined the effort to standardize networking protocols. So TCP, IP, Ethernet, HTTP, HTML, URLs, FTP. We joined the standardization effort. So those were the three enduring contributions of Ethernet, unlike the first three that I mentioned. Is there another question yet for me?
So when I the internet the first time, I really thought I'm, I would assume you didn't need that much numbers, so I think it was really wise to have such a big MAC address. So that astonished me.
So the first Ethernet, the one I just sort of described, had 8-bit addresses. And they were put using a wire wrap gun. The number was put on the backplane of each PC, and then that 8-bit number was used to select packets as they went by as to which ones you would copy into memory and which ones you just let go by. But then we went back to do the next generation of Ethernet, and in particular standard, submitting it to the IEEE. There was a big argument about how big the address field should be, and 8 didn't seem like enough. And they settled on, I wasn't involved in that argument, I watched it. The real reason for such a big address, they had the idea that manufacturers would be given clumps of numbers, and they would put them into the Ethernet cards. And so they wanted a big enough number so they could allocate them to manufacturers. So there were, and then Xerox kept track of who owned which numbers. And so that, I believe that was the key reason why such a big number was chosen. By the way, most people complained that it was too small a number, but welcome. Yes?
Yeah, I'm interested in the monopoly that you mentioned that you had to break. Can you tell us about that?
Well, 2 of them. When I used to drive from New York to Boston to go to college, my mom would say, Bobby, when you get to Boston, give us a call. Let the phone ring 3 times and then hang up. My mother loved me, but not that much. So there was a monopoly, AT&T, that was choking the telecom business. There's a beautiful picture of the 1950 telephone and the 1985 telephone, the Model 500. They're right the same. There was hardly any progress. All right, I'll give them progress for the Princess telephone. So that was one monopoly. You couldn't connect to the telephone network except using equipment owned by the telephone company. So modems were not allowed. Anyway, that monopoly was broken in the mid-'80s, '84, I think. The other monopoly had this neat way of doing computing. You would take your program and you would type it into a key punch that would put holes in a card. And then you take the card and put it in a deck. And then you go to the comp center and you submit your deck, which they then processed with a mainframe computer. And the next morning, you would pick up a big, thick printout of all your error messages. And that was computing in the 60s, the 50s, 60s, 70s. And that was the IBM monopoly. And I remember one of that monopoly also died around 84, 85. They were arguing about whether to go to 140 column cards. And they had 80. And they needed something more. So maybe we should go to a longer card. That was, anyway, those are the 2 monopolies. IBM had a network protocol. They called it SNA, System Network Architecture. I used to call it SNA. And they hated me for it. Anyway, SNA. Another question.
Hello. I have a question. So you created this back in the days, and let's say your baby grew quite a lot. How do you see it's going to grow further in the future? Do you have a vision, or it's already out of your control, let's say?
To be blunt, I think I like your terminology. It outgrew my vision a long time ago. I never imagined that there would be, every year there are billions. By the way, there's a big debate in my head about whether Wi-Fi is Ethernet or not. Now, it used to be called wireless Ethernet. And then in 1999, they changed the name, wisely, I think, to Wi-Fi. So depending on whether you count Wi-Fi which is a big number. There's billions of Ethernets being shipped every year, which far exceeds any vision I had for it. But Ethernet, it didn't just get more numerous, it also got faster, as you well know. It also learned how to take over the core and kill SONET. Remember SONET? It was a few-year synchronous optical network. It was an AT&T thing. It became my life's goal at one point to kill SONET. We did. Thanks for agreeing with me. And then mobile. The idea of a mobile video terminal, you know, we all have one of these, mobile video, that far exceeded any vision I had for the network. So I guess I don't think I'm qualified to be the visionary for Ethernet anymore, but it is going in many directions. I'm sorry, did I answer that question roughly? But only roughly. I didn't have it. Ask me what Ethernet is.
What is Ethernet?
You see, that's called a plant.
It's called a plant. I'm a shill,
Yeah,
as we
shill.
can call it in showbiz, okay?
So I've just convinced you that Ethernet was not Gerald Manchester Aloha Network. What is it? What is Ethernet? And does it include Wi-Fi or not? And so on. And the answer, my answer, after 50 years, this is close to the vision question. Ethernet is a brand. And I'm the brand manager. And what is a brand? A brand is a promise. It's a promise you make to your customers about what they're going to get when they buy your products. So Ethernet is a brand. So what is the promise of the Ethernet brand? And I happen to have a list of the promises. One is it's a result of de jure standards, IEEE 802. Two, it's native Ethernet, a native internet. It was built to carry packets in the internet architecture. So it's not a tortured reconstruction of the IBM terminal. It's a native mode packet machine. It's advances in Ethernet are usually accomplished with interoperability testing. During the heat of the battle, when Ethernet was fighting with IBM Token Ring and General Motors Token Bus, they made competing standards and used standard certification as their principal tool, whereas the Ethernet people used interoperability. So we would, I remember we all had booths. All of us Ethernet people had booths at the National Computer Conference in 1980 something. And we ran a yellow cable down the top of the conference center, and then we invited all the Ethernet companies to hook up to this yellow cable at 30, 40 feet in the air, and then demonstrate to customers that they had achieved interoperability among the products, which is what the customers wanted. So it was a very powerful tool. So that's a promise, interoperability testing. Build it and they will come. Repeatedly, Ethernet has been faster than was needed for about a day or two. And then the new applications come out of the woodwork and immediately fill it up. So build it and they will come as part of the brand. We're about to go into the gigabit, about to go from the megabit internet to the gigabit internet, and that phenomenon should recur, and the internet should fill right up again after.
The top speed that John D'Ambrosia's group is working on right now, 1.6 terabits a second. That's his speed that he's working on.
Yeah, but
right
he's
now.
cheating. They have this thing called lanes,
This is true.
which are separate lambdas. So I say to D'Ambrosia, give me a terabit on one lambda. That's what I'm looking for. Before I die, I want a terabit on a single lambda. So those are the promises. I'm sure I could think of some others, but those are the main promises of the Ethernet brand. So then people say, well, how long will Ethernet last? I mean, it's lasted 50 years. And that brand, you Google it up, there's a lot of mention of Ethernet, and there's conferences in Sao Paulo about it. How long will it last? And we cheat. We cheat. A new technology comes out, and it's about to obsolete Ethernet. So the marketing people have a meeting, and they say, what are we going to call this new technology? Ethernet is the obvious answer every time. You'd be foolish to depart from the Ethernet brand since it's been around for 50 years. So it's going to last a long time, I figure.
As you said, it's an innovation brand.
Right. Now, over this 50-year period, we brought a lot of connectivity to the world. In fact, I argue that the most important new fact about the human condition is that we are now connected, suddenly connected. When I say suddenly, I mean since October 29th, 1969, when the internet first began switching packets, we've added 5 billion users, 2/3 of the human race. That's suddenly. And that suddenness has led to pathologies, which are much in the news. I don't know if you remember the first pathology of the internet, a connectivity pathology. It's called pornography. And the United States government almost shut the internet down because it was so good at carrying porno. But instead they passed the Communications Decency Act of 1996. And so there's no more porn on the internet. And the next pathology of connectivity was advertising. And those of us who had participated in building the internet were appalled that our beautiful connectivity machine would be used to carry ads. It took us a very short time to realize that ads were going to finance the entire internet for the longest period of time. So the answer of how we're going to pay for all this connectivity was advertising. And the residual is called spam, and then we still have a little, but not that much spam. I mean, when's the last time you talked about spam? It's almost gone. Hacking is a pathology. I wrote the first memo in December of 1973 reporting 2 high school students had hacked into the internet, the ARPANET. So we've had hacks for quite a long time. And then there's fake news, which is the current famous pathology. And my claim is that we're going to deal with that pathology like we've dealt with the others. They eventually get dealt with, and they get lost in the noise, and that's going to happen to fake news. And if you ask me about it, I'll tell you, there's a bug here. Get away from me, you bug. By the way, I was born in 1946. I was very lucky because what do you think was invented the next year? The transistor. So the transistor and I grew up. And the word bug was first used in 1947, the same year as the transistor was invented. Other questions?
Yeah, I got one. Switching from technology to business. In my past professional life, we often refer to Metcalfe laws when we are specifying business cases for communication services and apps, and I think also Metcalfe law that n-square nonlinearity is also applicable to the staffing of an IEEE standardization working group. You need a critical mass of experts. Could you provide a little bit more background on the history on that law, how you invented it or described it?
Thank you. Well, in the early 80s, there weren't any personal computers. The IBM PC came out in, I think it was 80 or 81. 81, August of 81. So during the early 80s, there were hardly any PCs, and my company, 3Com, our purpose was to use Ethernet to connect PCs, so we had trouble finding customers. But we came up with a kit, 3-node kit, 3 cards, Ethernet cards, a cable to connect them together, and a diskette with software. And the diskette would allow you to share a printer among the 3 PCs, share a a file among three PCs, a disk. IBM came out with this huge disk in 1981, I guess it was. It was a 10 megabyte disk. I said, that's right, megabyte disk. Our customers didn't know what to do with 10 megabytes. It was more storage than they'd ever seen. So our software would allow them to share that disk among three PCs. And after a while, the customers came back and said, this kit does everything you said it would. It'll share printers, share files, exchange emails even among the three of us. But it's not really useful. And so we told them that the reason that their networks were not useful is they were too small. And the remedy to that was what? Buy our products. And they did. And we went public in March of 1984 on that basis. That principle, the principle that we used to sell them was the cost of the network was linear in the number of Ethernet cards you bought for $500 each. But the value, the number of possible connections you could make, one is the square. And the square overtakes the linear. And so we said, you need bigger networks. And they believed us, and it was true, and the internet followed. And that was called Metcalfe, in 1995, that was called Metcalfe's Law by a man named George Gilder. He wrote a book called Microcosm about Moore's Law, and he wrote a book called Telecosm about Metcalfe's Law. And I've been defending it ever since. There's a parade of professors and their students who think that the value of a network is not the square of its number of attachments. It's some other number. And it's my job to say that's ridiculous and go away. Other questions? Please.
Yeah, we are all here more or less related to the automotive industry. We have Ethernet since more than a decade in the car. Can you recall when you heard it first, bringing Ethernet in a car, what were your feelings? What did you think about this? Or maybe you had the vision even before?
So this relates to that vision question from before. Ethernet was not invented, for example, to carry video. It was impossible that these packets could carry video fast enough at 2.94 megabits per second. The internet now is 82% video, the traffic level on the internet. So, and then there was mobile. The internet was not developed for mobile traffic. In fact, the Sun workstation and then the IBM PC were the models of what a client would look like. But now most of the internet traffic comes from mobile devices, which we never intended. So along come cars. And the internet was never intended to network cars. But in the same way that it surprised, video surprised us and mobile surprised us, automobile Ethernet is surprising us now. Did you say a decade ago?
Yeah, more than a decade, I think. We have it.
And what was the functionality? Was it backing up, or was it automatic braking, or?
I think the first was the onboard diagnostic, simpler to put an PC on it.
I see.
And then pretty fast here, I think Kirsten knew it much better. So it was a vision system, the first demonstration. And this was a decade ago. Yeah.
Yeah, Bob, you may remember in 2014 when we had the Ethernet Alliance's technology forum in Santa Clara, and you were there. And a big part of what we talked about was the emergence of automotive Ethernet and how that would affect in the car and how having connected cars might affect the total internet.
Yeah.
Because that was looking kind of scary at that point.
So I just recently attended the 802.3 meeting in San Antonio, Texas. And there was a lot of talk about automotive Ethernet. And then I heard there was this meeting going to occur in Sao Paulo about automotive Ethernet. So here I am. I had to come see what you all were doing, arguing. Another question.
A more general question. You talked about the Ethernet brand before. How did you came up with the name Ethernet? So, is it like a name you imagined, or how did you came up with this?
So we, as I mentioned earlier, Dave and I settled on using coaxial cable as the shared medium. But it was a close call. We could have used twisted pair, we could have used optical fibers, we even considered radio briefly, but that didn't pan out. So we were reluctant to call it coax net, because if we called it coax net, that would be limiting. It had to be some medium that was passive and served as the medium for the propagation of electromagnetic waves. And what is that? Well, that's called the ether. The physicists used to call it ether, that medium between the Earth and the sun that carried light. So it was called the luminiferous light-bearing ether. So since it was disproved, the ether does not exist in space. That was proved around 1905. The word was floating around unused. So we scooped it up and we said, we'll call it Ethernet, and that way we could change media later, and we did, of course. So now it's back to radio. So we had a big fight there was a physicist at the Xerox Palo Alto Research Center who sent a memo to my boss's boss attacking Ethernet. He's a physicist, because it was not quantum noise limited. And it was pretty terrible what he did. He didn't call me up and ask me about it. He just fired this memo off to my boss's boss. And I, therefore, had to go defend it. Because he didn't get the idea that the cable was basically free. So if we wasted the cable, that's not a problem. And we did waste the cable. We ran at 2.94 megabits per second on a half-inch piece of coax. Is anyone curious why the first Ethernet ran at 2.94 megabits per second? Yeah, there's one curious. There's two. Oh, there's a few people. Is it because the cable couldn't carry more than 2.94 megabits per second? No. Cable could carry hundreds of megabits per second. I mentioned the Manchester encoding. So the Manchester encoding is very low utilization of frequency. So it's 1 bit for 2 bauds, as I recall. And so we were almost done with the card, and we put the Manchester microcode in there, and we had no more space for a clock. There was no, for the crystal and the passives that go around the clock. But then Dave Boggs remembered that on the back plane of the Alto, there was a system clock that ticked every 170 nanoseconds. So instead of having our own clock, we just said, we're going to run this network at 2.94 megabits per second. Dave, why don't you write a requirements document that requires 2.94 megabits per second? Anyway, that's how we ended up at 2.94. It was a real estate issue. As I mentioned much earlier, we had the constraint that whatever we built had to fit on that 60 chip card, and so we got the 2.94 in there. And by the way, I don't say 3. Over the 50 years, people have frequently said, well, just round it off to 3 megabits per second. But I refuse. In 1973, the transcontinental trunks of the entire internet ran at 50 kilobits per second, which is the rounding error on 3 megabits per second. So I refused to go to 3 because then the whole internet became rounding error next to Ethernet. Other questions?
So you've seen a lot of technologies coming and going, also companies coming and going. A question would be, how do you foster innovation in a company?
Now That's a much harder question than any of the ones that came before. So how do you do innovation? Is that what you asked?
Yeah, how do you foster innovation in a company in general?
Well, there's two ways. One is you stay in the company and figure out how to innovate, or you leave the company and start a new company that and that's what I did. I left Xerox and started 3Com. But I could have chosen to stay, and some people did, to stay at Xerox and innovate in there. And this is a special case. The innovation of connectivity is a special case of innovation because of the role of standards. Most innovations don't have such a central role of standards as we do. We are all stuck with standards. And so that changes the answer slightly, because that means you have to leave the company to get, not leave the company, but go outside the company to get standardization. Whereas a lot of other innovations don't require that you do that. You can do your own thing inside the company. But my main answer to your question is ecosystem. The startup ecosystem, which can sometimes operate within a company, but in Silicon Valley, for example, typically operates outside the company. And so if you focus on the ecosystem and finding your proper role in the ecosystem, that's where the innovation gets done. So so we have a startup ecosystem in Austin, Texas. There's the famous one in Silicon Valley. Boston has one. And incidentally, Silicon Valley used to be in Boston. When I was a student there, I did startups, and I worked, DEC was a Digital Equipment Corporation, was a startup in Boston. But around 1972, when I moved to Palo Alto, Silicon Valley moved to Palo Alto. I'd like to believe it's because it followed me, but I don't think that's it. Why? Why? Well, first there's why was it in Boston to begin with, and then why was it in Palo Alto? And I think the answer is a law, Grosch's law. So there's Moore's law, Metcalfe's law, Grosch's law. And Grosch said that the computer's cost grows as the square root of its power. And he worked at IBM, and he sold big mainframes, so it was self-serving. His law was very self-serving. Buy bigger computers from IBM. Whereas Moore's law was taking off starting in 1965 in and around Palo Alto, and Moore was right and Grosch was wrong. And that moved all of us people over to where the action was in Palo Alto. So I think that's why it moved. And another reason it moved is there was a guy named Shockley, William, who invented the transistor. And so after he worked at Bell Labs and got his degrees from MIT and got his Nobel Prize for inventing the transistor, he learned that his mom got sick. So he went home to take care of her. And where was his home? Palo Alto, California. And as soon as he got there, he started the first semiconductor company, Shockley Semiconductor. That's, I think, why Silicon Valley happens, or the biggest Silicon Valley happens to be in and around Palo Alto. Other questions?
Yeah, so you mentioned that Ethernet keeps on being reused and reused when there's a new technology that comes in, but it keeps somehow its spirit or its ground structure. So I think I remember reading a statement, I don't know if it was from you or a book you wrote or something, that says, Ethernet weight always wins, something like this. So can you, I don't know, give us a little bit more glimpse in, well, why does it really always win, Ethernet?
So in 1979, we decided to make Ethernet a standard. And so we called the IEEE and created a project, which met in February of 1980 at the Jack Tar Hotel in San Francisco, California. And that was Project 802. There were no dots. And As soon as we did that, two other companies noticed, IBM and General Motors, both of which came to the IEEE 802 with other technologies, the token bus from General Motors and the token ring from IBM. I remember telling the General Motors guy, why don't you guys make cars and let me make the network? But no, General Motors had to make its own network, which took us a couple of years to kill. But the IBM thing was much more serious because IBM was 90% of the market, of the computer market, and they had this damn thing, the token ring. So a fierce battle occurred. Another one was ArcNet, which was actually the numerical leader at the time. And it got to be a really nasty competition that lasted for a decade or two. And so and Ethernet won. I'm going back to your question now. That big battle, oh, by the way, the IEEE courageously standardized all three networks, which in one of its weaker moments. So they standardized Ethernet, IBM token ring, General Motors token bus, and then let us fight it out in the market, which we did fiercely. And Ethernet won. And hence, somewhere along the line, someone said, never fight Ethernet, or the Ethernet or Ether not. It was another characterization. But imagine coming to work every day and having your board of directors and your wife and your employees tell you that IBM was going to kill you for 10 years. And then in the end, you won. Can you imagine what a monster that creates? You know, I never take advice from anyone anymore. You know, I was right that time. So those expressions came out of the fierce competition that the IEEE created by making all three of them a standard. ArcNet shipped product in 76, I think it was, maybe 5, ahead of everybody else. And they had an installed base of tens of thousands of PCs. And the IEEE deputized me to go ask them, will you submit your ArcNet specs to the IEEE for consideration as a standard? And the Arc people, Data Point was the name of the company, thought about it for a month and came back and said, no, we are not submitting our specs to the IEEE. We are going to go proprietary. And they lost their lead. They didn't, when you go down the tubes of networking, it takes a long time. But so ArcNet, an early victim of that competition. How are we doing on time? 40 minutes, oh my goodness. I don't think that, I'm looking at this group, most of them are asleep. Is there any more questions?
Yes. So do you have a memory of an aha moment where you were stumped for a longer time, like a technical or a business moment where you say, okay, you really struggled with this problem, that you now can talk about it, and what was the final result and how did you solve it?
Well, I have a bunch of those. I've been accumulating them for a long time. One of the worst ones was I worked on the ARPANET. The ARPANET was the first version of the internet. It began switching packets in October of '69. I joined in January of 1970. I joined MIT to put MIT on the ARPANET. And then I wrote it up. I was a student at Harvard as a PhD student. I hated Harvard. We didn't get along, but I was a student working at MIT on my research for Harvard. So you can see the beginnings of that problem. So in 1972, I showed up at Harvard to defend my thesis. And I failed my oral defense of my thesis. And this is 2 weeks before graduation. My parents made hotel reservations to come watch their son graduate with his PhD, and I had to call them up and tell them not to come. They came a year later. Say again? Oh, no. It was an actual phone call. But then I had a job all set up at the Xerox Palo Alto Research Center. So I called Bob Taylor, who was my boss, would be my boss, and I broke the news to him of it. I was not going to have a PhD. And he said, listen to this, he said, oh, just come anyway and finish your dissertation out here in Palo Alto. Whew. That was a lifesaver. Oh yeah, my wife had gotten a new job. She quit her job at MIT and was working at Stanford. And that had to unwind. So that was going back, I forget who questioned, but that was a depressing time to have, and I was saved by Bob Taylor. I have 50 more stories like that. What were we talking about? Oh, failure is learning.
Right.
Failure
It's learning.
is learning. Yeah,
Right.
Don't let failure get you down.
Yeah.
It's
Yeah.
learning. Question?
Yes.
Question?
You've been like an employee at Xerox, for example, and then you became an entrepreneur and set up a Tricom. What's the difference between
Between staying at Xerox and going to 3Com?
being an employee and being an employer? And what the house is to run a company in the US or in California?
So I left Xerox to become an entrepreneur because that's what everybody did in Silicon Valley. I didn't really have a good idea. And then I gave 7 months notice. I told Xerox I was leaving to pursue entrepreneurial ambitions. I did not never slam the door behind you, because I turned around and made Xerox my customer after leaving. I went to Xerox headquarters in Stamford, Connecticut right after founding 3Com. It was the first time I'd ever been there. So I had to leave Xerox to get to the headquarters of the company. And then the first thing you realize, there's this myth that people I want to start my own company because I want to be my own boss. That's silly. You have 100 bosses now. All of your customers are your bosses. Your suppliers are your bosses. Your shareholders are your bosses. So don't believe that about becoming your own boss. Then there's the problem of recruiting. You're starting a company, huh? They say. And a lot of people won't join your company because you don't have really a company. So I made a bunch of bad hiring decisions, like my fraternity brothers and my girlfriends and other things like that. And I had to clean that up after a while. When the VCs showed up, they said, what's this? What's this? What's your fraternity brother doing that? So, but I couldn't get anyone else to join the company, so I was stuck. And those people, by the way, all did well. They all had stock options, and they eventually made well, but not as employees of the company. I've lost track of your question. What's the difference between? I interviewed this engineer, and he was inclined to join the company. And he asked for two things that were really hard. One is, he said, this letter here has a stock option in it. I don't understand stock options, he said. I just want you to tell me that when we go public, I won't be embarrassed by this number. So he threw it back on me, and I said, that's a good number, you should take it. And he did take it, and he got a house out of it, which was the coin of the realm, getting a house in Silicon Valley from the IPO. The other thing he said is, by the way, my wife's pregnant. I want to have medical insurance. I didn't have medical insurance. So I had to go out and figure out how you get medical insurance, including pregnancy insurance. It's not called that. Anyway. So that's a difference. At Xerox, that was all automatic. Somebody took care of that. But when it's your company, you take care of that.
So Bob, while we're on the subject of a startup, one of the things I assume you had to do is go out and chase down venture capital for the startup. So maybe you could share some of your experiences about doing that, and then later in your career, you became a venture capitalist.
It's true.
Yeah. So I think some of these folks would probably be interested in hearing about how all that works.
So I mentioned earlier about the startup ecosystem, and Silicon Valley has one. And an important part of that ecosystem is the venture capital community, which is fierce and been there for a long time. And most of them have their offices on a road called Sand Hill Road in Palo Alto. And I was living on Sand Hill Road in an apartment. And so I went to the office of the Western Association of Venture Capitalists, and I got their directory. And then I started calling. While I was working at Xerox, I started calling the VCs over a period of 2 years until I'd met them all. And the saying, which I recommend, is if you want money, ask for advice. If you ask for advice, you'll get money. So I eventually raised $1.1 million for a third of my company. That's an awkward number. So the first round was we were consultants for a couple of years. Then we raised this 1.1 million. Then the next year we doubled the valuation of the company and we raised 2.2 million. And then the next year we doubled the value of the company and raised 4.4 million. And then in 1984 we went public and we raised $11 million. These are laughable numbers now. And that's all we needed, was that $1 million in the IPO. So the venture capital part of the ecosystem performed for us. You will frequently hear complaints about it, but I had the best board on earth. These are VCs who'd been doing it for decades, and they were on my board, and that felt good. And they performed. What else about that was?
That later in your career, you were the guy on the other side. You were the VC people were coming to.
Yes,
to
I
get
became
money.
became a VC in the year 2000. I was for 10 years. We had a $4 billion fund. I had 12 partners, and we had $4 billion to invest. And it's a lot of work. The hard part is saying no, but you have to say no 9 times out of 10. That's, the batting average is pretty low for startups.
One more to follow on that, because I think, again, this would be interesting. As a VC, how do you evaluate those bright people coming in and saying, hey, we've got the greatest idea in the world, can you please help us with some money? You know, how do you look and say, I think these guys have really got it, and that these guys maybe don't?
Well, that's a very hard question.
Yeah, I figured it was. I'm just curious what your own personal...
Well, there's 3 things. There's the people, there's the technology, and there's the market. And the good VCs, of course, evaluate all 3. But most VCs specialize in one of those 3. And I specialized in founders. I fell in love with founders. This is not good. In the 10 years I did VC, I learned that it was better to put energy into selecting the companies than trying to help them. So instead of investing in a company that's a little shaky and trying to fix it, that's a fool's errand. So it's better to put more energy into selecting, finding, doing due diligence on companies than it is to, the conceit is that I once ran a company so I can help them run theirs. No, that is a poor investment thesis. I didn't hear half of what you said. What's the question? Did someone else hear the question?
So you've mentioned the ARPANET as first version of the internet. I think the packet node, the first packet node was called Interface Message Processor.
IMP.
Operated by Leonard Kleinrock, MIT. I'm curious, did you work together with Kleinrock?
I've never heard the name Linehawk.
Never.
Never. Linehawk.
Kleinrock. No, Kleinrock? Never?
Oh, Kleinrock?
Kleinrock, yes.
Leonard Kleinrock.
Right.
Oh, yes, yeah. Professor Kleinrock was senior to me. Even today, he's in his 90s now. And he's still amazing. But he had imp number 1. I had imp number 6. And he was at UCLA, and he did the first network login over the ARPANET. And so there he was at UCLA, and one of his grad students, Charlie Klein, decided he would log in from UCLA to SRI, Stanford Research Institute. And he sat at the terminal and he hit L for login. And L got echoed. So he hit O for login, and the O went to SRI and came back. And then he hit G, and the computer crashed. So that, but then Lenny Kleinrock, I'm sorry I didn't understand his name at first. He likes to say it was a religious experience. Lo, log in, L-O. Lo and behold, the internet is born. And that was October 29th, 1969. Excuse me for not catching Kleinrock.
What was the most difficult moment in your career and the best one? The most difficult moment in your career.
So I have a lot of them. So, but here's one. I was running the company, and I had recruited a president of my company, so I was chairman and CEO. And I'd raised this 1.1 million. Oh, I'd raised I'd raised the 1.1 million to pay the salaries of 10 people. So you can imagine cash is going down and down and down and down because we didn't have much revenue. And one day there was a board meeting. I was chairman of the board and the majority shareholder, but the board of directors decided that I couldn't be CEO anymore. That was a horrible moment. So what founders in the Valley generally do when they are not CEO anymore, what do? They leave and they slam the door behind them and they say a lot of nasty things about it. I didn't do that. I said to the board, what do you want me to do? Put me in, coach. And so they made me vice president of sales and marketing. That's how desperate this company was. And so I had to learn, and we were running out of cash. And I got us from 0 to $1 million a month in the next 2 years, and then we went public. So I learned how to be a vice president of sales and marketing really fast because we had no choice. But that moment when they told me that I wasn't CEO anymore, oh God, that hurt. But I recovered because I remembered what I had told the investors. I told them there were a series of mistakes that I would not make. And one of the mistakes I would not make is insist on running the company. I wanted the company to be successful more than I wanted to run it. And this was that moment. And so I hurt for a while. Then said, put me in, coach, and they gave me the job, VP of Sales and Marketing. I recruited 6 salespeople. It turns out you don't get any orders unless you ask for them. And we didn't have any salespeople, so why should we be surprised we didn't have any orders? So I recruited 6 regional managers, and suddenly not suddenly, but we had revenue suddenly, and made it to our next round of finance. And one of the funny things was one of the 6 guys, I gave him the central United States and the rest of the world. And I gave him the rest of the world because he was English. He had an English accent. So I made him head of England. Anyway, he succeeded. Fortunately for us, our 6 salespeople succeeded. and the company lived on.
Hey, Bob. You know, I've done Ethernet since mid-'80s, and I've done 10 base 2, if you remember, the yellow cable, the 10 base 5.
Do I remember?
Yeah, of course. You invented it. You invented it. Or you chose it. And then the twisted pair and all of that. But one of the experiences I want to share and see if you you know about it, or maybe can, is in collision domain, right? You talked about AlohaNet and random backoff and all of that. One of the big challenges that wasn't obvious at all, and there were significant field failures, kind of memory land, is when you did the random backoff, right? To figure out another time the randomness itself, right, for many manufacturers was the same, right? I mean, how do you create a random number? That's a very difficult thing to do, right, back then. So I was at National, and
We solved that problem.
you solved it, right? Can you tell me about that? How did you solve it? I'm very curious, because that's...
But we did and we didn't. So the problem is called determinism.
Yes.
And it's the big issue in this meeting. We call it TSN. But determinism was a problem then, and IBM used determinism against us to try to kill Ethernet. But we had solved the problem. In the microcode, when there was a collision, there was a word that had ones in it, and we would shift it over one and it against the system clock. Not a high-quality random number, but good enough. So we would AND it against the system clock. If there was another collision, we would shift in another one, thereby doubling the mean of the retransmission interval. And it worked.
That's brilliant. That's brilliant. Because if you don't do that, one of the biggest challenges we had at National, but if you don't, then all of our chips would random back off the same, and the system would never resolve. So that's good to know. That's good to know.
Yeah, phew, close call there. But here we are 50 years later, and determinism is still an issue here. And
System clock does it, right? Because system clock, depending on unit, and no two systems are exactly the same clock at the same time. Very good, thank you.
Well, they were unsynchronized clocks.
That's right, that's right, that's right. Very good point, thank you.
I have actually two questions. One thing is, can you talk a little bit more about the change from being a super high-techy and move to the sales area? I found that very interesting. And the second question, as you mentioned, TSN and determinism, how much of a change do you see that for Ethernet to become a deterministic network rather than to a best effort network?
Those are two completely different and very hard questions.
Sorry.
So I became head of sales and marketing and of 3Com, and we had 0 revenue, which is a really low number. So I went on a recruiting binge and recruited 6 people: Northeast, Southeast, Northwest, Southwest, Central, rest of world, so on, and started producing product literature, sales and marketing. So I quickly learned the difference between sales and marketing. Marketing makes tools for sales. So I started making, Metcalfe's law was a sales tool I made for the sales force. And then we started calling on people. The reason that my board made me head of sales and marketing is because they believed it was a very technical sale and that I could get access to decision makers because I was the inventor. So it wasn't my sales ability, it was my ability to, based on my history, of being able to get in and talk to people. And then I learned that engineers and salespeople are different. They're both carbon-based life forms, but completely different. And then the engineers complain that the salespeople are paid more, which they generally are. And my remedy there was to take the engineers on sales trips with me, and that cured them immediately. And they wanted to go back to engineering again. I plotted on my cubicle a yellow graph paper that engineers have a lot. And I'd put the month there, and then I would put the sales target, and I would draw a straight line from 0 to the target. And then every day I would plot the sales as they came in. And as long as that number was above the line, I was a happy person. And when it went below the line, I became suicidal. It was a big morale thing. Remember that? Traveled endlessly. That's not good for you. All right, so what was the other question? I don't think of best efforts. Oh, I see. You're saying the TSNs, since it schedules transmission, there were no lost packets, whereas, I see. I always viewed determinism as a solved problem. In fact, I just described the solution. We used a system clock, ANDed it against a shifted number, and we shipped it, and it worked. And my co-inventor, David Boggs, he got really tired of having the IBM thugs disparage our invention on stage. And he built 100 Ethernets, and they were still telling him it wouldn't work. And he was at a conference in San Jose, and he said, "It seems that Ethernet works only in practice, not in theory." Because they had all these models that showed that the collisions would just somehow blossom, and they didn't. The model was wrong.
Yeah. Question over here. What's the future of Bob Metcalfe's ventures? I heard something about AI. Is there something you can share of what your next big venture is going to look like?
Yes, and it's not AI. That was a misreporting. That was fake news from my... Well, yes, but it's the Computer Science and Artificial Intelligence Laboratory. Yes. Now, it turns out that in 1968, I had an undergraduate thesis advisor at MIT whose name was Marvin Minsky. And Marvin was, roughly speaking, the founder of artificial intelligence in 1968. And the title of my dissertation was A Neuron Model and Some of Its Information Processing Capabilities. So I submitted it to Marvin, and I could tell Marvin didn't think I was smart enough to be in artificial intelligence. So he sent me down the corridor to go work on networking, and that worked out, so yeah. Yeah, I could say that, yeah. So I'm on my 6th career, and I'm just starting it, so it's a bit awkward. I have no results to show, but I've got myself hired by MIT to be a computational engineer. Not computer science, computational engineer, meaning using computer modeling to understand complex systems. And I'm working on a model now of Ethernet because I want to dig into that question you just asked. But I'm also working on a model of a geothermal well, deep, closed-loop geothermal well. The problem I have there is that in order to do a model like that, you need to know thermodynamics, which I didn't take. So I have a bit of a divergence. I'm using the internet to take thermodynamics. So computational engineer so I hope to have a number of engagements of varied topics. And I'm just starting, so I have nothing to report.
Thank you. So normally when you want to develop a successful product, you need to innovate, and maybe 1 out of 10 will be successful and it will be really cool. So how is your success rate? So how many fails did you see?
All right, so when I was still an undergraduate at MIT, I started 3 companies, all of which lasted a year. They were consulting companies, they paid tuition, and then they vanished. But you could view those as failures, sort of. They were called management systems consulting, data concepts design, and professional data services. So you can see I put more energy into naming the companies than into actually writing the computer programs. But then I moved to Palo Alto and became a computer scientist for 8 years, and then started 3Com. 3Com was very successful. At one point, I love this number, at one point, 1999, 3Com was worth, inflation adjusted, $70 billion. And I didn't even get half of it when we sold it to HP. Yeah. I didn't even get half of it. Yeah. So it was very successful. So one out of four. That's right. Never thought of it that way. Yeah, it's not bad.
So Bob, just a commentary because you keep talking about token ring. 1989, I was at National Semiconductor. IBM had significant force. They were a market force. So they came and said, let's do a joint Ethernet token ring chip. So I actually let that be Triangle Park. And we came out with a chip which was a combination of national Ethernet controller and a token ring, and we started marketing it. And no customer that I know of, or very little customers that I know of, ever turned it on into the token ring mode. It was all Ethernet, 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 and then they pretty much saw the writing on the wall, right? I mean, you have a chip, you're providing it to these, system vendors, nobody is using it. So to your point, right, they push, but just ultimately Ethernet won. So.
Before your report there, Texas Instruments had a token ring chip. And my company, my board of directors made me make a token ring card with that chip. Bob, you can't run your company into the ground just because you're stubbornly connected to Ethernet. So we ended up shipping token ring. But IBM was cheating, and their token ring card required software that we didn't have. And so it was very hard to sell these cards. And eventually we punted, and eventually, well, years later, they punted also.
Very interesting.
Token ring was slower, more expensive, horrible, yeah. Terrible. It was a terrible product.
Spent 6 months of my life in Triangle Park doing that project, so know exactly. Thank you.
Sorry, I apologize.
Okay, we got about 13 minutes left. Come on, you guys, you gotta have
another one?
questions. Yes, sir.
So when you took over for vice president of sales, what was the product at that time? What were you selling?
We're selling 4 products. I sold all 4 products to Exxon Corporation. I gave them a worldwide perpetual non-exclusive license to resell the 4 products that we built for them. An Ethernet transceiver. Oh, in those days, the transceiver was off-board. It was a separate box up on the roof. So we did one of those, and then we did a Ethernet card for the Unibus, for the Q-Bus, these are 2 DEC machines, and for the Multibus, which was Sun Microsystem. And then we became Sun's Ethernet supplier, we were selling hundreds per month at $1,000 each. So then, having gotten $750,000 to deliver these products to Exxon, which we did, I then turned to raise venture capital. And the venture capitalist said, you just licensed the world's largest company to compete with you, with your own product, you idiot. And I said, Exxon is an oil company. They are never going to sell these products. Invest now. And fortunately, you don't have to get the entire venture capital community to invest in your company. You only need 1 or 2 or 3, and we got 3. And then we use that money to market going to your question, to market those 4 products. So we sold Ethernet transceivers and Q-bus, Unibus, and Multibus. But then came 1981, and IBM announced the IBM PC. And I said, hey, maybe we should do an Ethernet card for the IBM PC. And my head of engineering, who was treating me like the head of sales and marketing that I was, said, we already have an engineering plan for the next year, and it does not include the IBM PC. Okay? So I went and I bought an IBM PC, and I brought it to work, and I got a folding table, and I put it against the wall. And then I took the IBM PC out of its box, and then I unscrewed the screws, and I opened it up, and then I walked away. And the engineers flocked to this. And later that day, it was in our product plan to develop that card. And it was called the EtherLink, and it was the card that made the company. We sold it for under $1,000. It was for an IBM PC. It was about this big. Had the transceiver on board. That was the big step forward, actually. And then, did I mention we sold hundreds of cards to Sun? This card we eventually were selling 1 million a month. It was a big success, the EtherLink.
So one of the things that always fascinated me about Ethernet, because I started using it in like 1985, was the fact that it was system agnostic. You could get Ethernet cards for different computers, different OSs. It was the thing that would connect them all together. And maybe for you younger people who didn't experience the world before, where everything was proprietary and nothing talked to anything else, this is a huge deal. And I know in the Ethernet memo where you talk about, renaming it from the Alto network to the more generic, it says right here, because we should support any number of different kinds of stations, say Data General Novas or DEC PDP-11s. So from the get-go, you said that you wanted to support pretty much anything. Was that your decision, or was that kind of something that they wanted done at Xerox?
Well, it should be familiar to you. It was the intent of the internet.
Right, and that's kind of what I thought, but
so I guess we got it from the internet. The internet was the first time that DEC was going to have to stop using DECnet and use internet, and IBM was going to have to stop using SNA and use internet and Data General. So putting Ethernet into that machine was natural.
So
there's 2 benefits to having a communication standard, and we experience both in spades. One of them is your customers have choices. They have competing suppliers of Ethernet. And so we had a lot of competition, including those national people. And, but the other benefit is the benefit of connecting things together and making them more valuable, like sharing a printer and that's Metcalfe's law kicking in. We had the benefit of those 2 advantages. The customers loved the idea that they would have a choice among competition, and they got the benefits of the value increases of connecting things together. And you could see it. You could see it happening in sales situations.
Okay, so I have a question. In '95, you predicted the imminent collapse of internet. Can you tell us a bit the story behind this, and what made you?
Did you say the collapse of the internet in 1996?
You made the prediction that soon after you canceled.
Yes, in 1995, I was writing a column for InfoWorld. I had 1 million readers a week, and I had to be interesting every Thursday night. And this one Thursday night, I decided that the internet was going to collapse next year. So I wrote a column announcing that the internet was going to collapse next year. And I had good reason. I mean, I could watch the web was new, the traffic was surprisingly strong, and I could tell with my instruments that about 1/4 of the TCP packets were being lost. And this was going like this. So I had some basis for predicting that the internet would collapse. And then I gave a speech at the World Wide Web Conference in Santa Clara in '95, and I told them all the internet was going to collapse the next year. And they made me promise. Imagine 1,000 bloodthirsty web users. They made me promise that I would eat my InfoWorld column if it didn't collapse. Guess what? It didn't collapse. So in 1997, I went back to the World Wide Web Conference, and I ate my column. And they loved it. And it was great show business. It was called, and there's a book about this. I wrote a book called Internet Gigalapses, because I predicted that 1 billion lost user hours in a single outage. That was the gigalapse. It did not occur, and so I ate my column in '97. Are you happy now?
On the 3Com activities, after you were VP of Sales and Marketing, how did it carry on? What was the next history on your journey there?
It turns out sales and marketing are very complicated. And me being head of sales and marketing was amateur night. So as soon as we went public, we recruited a real VP of marketing and a real VP of sales. And I was already chairman and majority shareholder. It's great being majority shareholder. I recommend that highly. So then I started a software division, and then I started a workstation division. Then eventually I became head of all of hardware. And then I got fired again. And 10 years later, my board of directors chose another person to be CEO, not me. So, and both times it worked out. So they were vindicated in their wrong decisions. So that's what I did afterwards. I played other roles at the company. My most fun, I loved doing public relations. And my marketing person hated this because she wanted to run public. That's what marketing people do. And I said, no, I like PR. I'm going to run PR. And I did that. So I did that also.
So Bob, just a technical question. Very curious that in early 80s, you know, for the coaxial transceiver interface, was it discrete or was it actual integrated circuits, right? Because to put it in an integrated circuit, it's a different skill set of, did Xerox have it or how?
No, this is a great story.
Yeah.
There was another startup called Seek Technology, S-E-E-Q. And they partnered with our arch enemy, Ungerman Bass Incorporated, to build the first Ethernet chip. And they got started, but then they made a mistake, and they got in a fight with their venture capitalist. Ralph Ungerman was his name, and he got in a fight with John Doerr of Kleiner Perkins. So John Doerr comes to us and says, I'm not working with those people anymore. Would you like to partner with Seek to make the first Ethernet chip? And so then we broke a rule. The rule is you never make two startups partners. Because as you know, the product of two small numbers is an even smaller number. But we partnered with Seek, and we designed the Etherlink with a socket, hoping that that chip would arrive in September of 1982. And a miracle occurred. In September of 1982, Seek delivered the chips, we put them in the sockets, and we shipped those products. Life was good. And so we took a long shot, which is to rely on this startup, and they were relying on us. And the other stroke of luck was that there was something being created called the retail channel, where you could buy PCs at retail. So we introduced the Etherlink into retail, because IBM wasn't going to help, so we had to go around IBM and go through retail.
Very interesting, thank you.
So we're about 1 minute out, so now's your chance, okay?
Who was the best partner you had in your career?
Best partner?
Yeah.
Let's limit it to business. And his name was Howard Charney. He was my fraternity brother at MIT. When it came time to incorporate 3Com in June of 1979, I needed a lawyer. Howie Charney was a patent attorney in San Jose by that time. So I called him up. I said, I need a lawyer to incorporate my company. He said, I'll do it for $300. Sent him the $300. He incorporated 3Com. And then I said, hey, Howie, why don't you come work at the company? He said, okay. And he became head of manufacturing. And yeah, well, he had an MIT degree in mechanical engineering. And he was a lawyer. He had an MBA and a JD, endlessly educated. But he became the world's best manufacturing guy. So we were producing 1 million cards a month from Howie's factory. He had all the systems, the spreadsheets, everything. So part of our success could be traced to the reliability of our factory. And we didn't make too much, we didn't make too little. We made it cheaply, high quality. At one point, it was typical in the computer industry in those days to have a 90-day warranty. You would ship the product, and then the customer could return it in 90 days, no questions asked. So we had a meeting one day. We noticed that none of our cards was breaking. Howie was making these incredible cards that just worked. He had a shake and bake system where he would build them and then he would put them in a machine overnight at cycling temperature and vibration, and then there was some infant mortality, but after that, the cards worked forever. So at the marketing meeting, we decided to make it a lifetime warranty. So we announced with big fanfare, buy our cards and for the rest of your life, you can return them if you want. The customers loved this, and how he made it possible. So I would say he would be my best business partner, Howie Charney.
If you have one, what's your secret phrase to remember the 7 layers of the OSI model?
Physical, link, network, then it's application, presentation, session, and there's another one in there. I don't know what the other one is, but no, I don't have a way of remembering. But okay. That was pretty good. I got at least 6 of the 7.
I agree. Yeah.
Yeah. And that's a very important list. The internet owes much of its success to the early adoption of the 7-layer model. And that allowed people like us to make Ethernet cards while Tim was making the World Wide Web. It's a miracle, the internet as we know it today was basically invented in 1973 with TCP/IP. And the World Wide Web wasn't invented until 1989. And it worked on top of that old plumbing. And it was the layering that you just asked about that made that possible.
All right, folks, thanks. We're at the end. I think this has been a wonderful experience here. Bob, as always, thank you so much. So everybody, come on, let's applaud.
Thank you.
All right. All right, well, thank you so much for coming here. And I hope you've gotten something out of getting to talk to the guy who made it possible for us to be here in the first place and who still continues to find new careers, which I find that just awe-inspiring, frankly. And you'll have to keep me apprised on how that's going because I will be interested. So we are done at this point. So Thomas, should we just send everybody to the dinner or what do you want to do? All right, so I'm being told by... Right, that was why I kept asking you. So, all right. So, Bob, we have something for you. If you'd like to come back up on the stage, we can leave the notes here. All right, so why don't we come on the stage so everybody can see. All right, so let me hand you the microphone and you can do the honors.
So, the Computer Networking and Distributed System Technical Committee of the Brazilian Computer Society and the Brazilian National Computer Networks Laboratory honor the pioneering contribution of Professor Robert Metcalfe to the Internet Foundation and its profound impact on modern life for intercommunication and social inclusion.
Wow, thank you.
Congratulations.
And Metcalfe has an E at the end. And you got it right.
You got it right.
Yeah, that's great.
Thanks to Google.
Thank you.
All right, everybody, thanks. We're done. Let's
Thank
go
you very
have
much.
a
Yeah.
networking dinner in session.
Wow.